Now we'll let this sink in, and instead of confusing you. Now, this homework for part 6 and part 5, of course, was balancing equations. Both part 6 and part 5 are due by midnight on Monday. Yeah, things are due Mondays and Thursdays in this class yet. So, all right, here we go. Ready, set, go. Okay. So when I'm going to erase this. Let me know if you need the contact information again. When we balanced an equation, for instance, just the decomposition of water, we say 2 moles of H2O will decompose and give us 2 molecules of H2O will decompose to give us 2 molecules of H2 plus 1 molecule of O2. I put little squiggly marks here underneath the, what do we call the 2, 2, and 1? What are those called?
Stoichiometric coefficients.
Easy for you to say. Very good. Yes. They're called stoichiometric coefficients. Yes, exactly. Stoich. Yep. So, this idea of stoichiometry. See the word there. Stoichiometry, stoichiometric coefficients. Now, when we put the 2 in front of the H2O and the 2 in front of the H2 and left, actually, I'm going to erase this 1 so it doesn't confuse us. Leave nothing in front of the O2, which is implied 1. We are saying the relative amounts of H2O you start with and relative amounts of H2 and O2 that you end with. Generally speaking, that is what we call the stoichiometry of the reaction. So the stoichiometry of the reaction is just relative amounts, and it's indicated by the stoichiometric coefficients. See the same word there? Okay. Cool. So we talked about 2 types of equations, balanced and unbalanced, and only if the equation is balanced do we get relative amounts. Okay, so this is balanced. And when I balance this, I like to think of it on a small scale. I like to think of the 2 magnesium atoms, 1 molecule of O2 goes to form 2 formula units of magnesium oxide. We use the word formula units instead of molecules because magnesium, I know, is a metal, makes magnesium oxide, an ionic compound, and a repeating unit is a formula unit. So we also know that a mole, you guys, I've been looking at some of your Alta homework. You guys got this beat into you. How many, if you have a mole of particles, how many particles do you have? Yes. 6.022 times 10 to the 23rd. You guys got that totally down. So those stoichiometric coefficients can be the relative small pieces. They can also be the relative number of moles. So actually, we could say that 2 moles of magnesium atoms react with 1 mole of O2 molecules to form 2 moles of magnesium oxide formula units. Okay? So you guys told me these are called stoichiometric coefficients. You guys got that down. Relative number of particles. So we're gearing up towards a classic calculation in chemistry, there, called stoichiometric calculation. All a stoichiometric calculation is, and I'll kind of draw our attention to the decomposition of water. All a stoichiometric calculation is you have like an amount of something and you're trying to find the amount of something else. So it's 2 things. You can pick, they can both be reactants, they can both be products, but a stoichiometric calculation is simply going from the amount of something to the amount of something else from a balanced equation. Okay. That's it. We do it all the time. I liken a balanced equation to kind of like a recipe where, these would be our ingredients, over here are reactants, and these over here are products. These would be the thing that we make. Okay, so we're already kind of used to this idea, relative amounts. Okay, so we are actually going to use our stoichiometric coefficients to create stoichiometric ratios. There's lots of stoichiometric things going on here. Stoichiometry, stoichiometric coefficients, stoichiometric ratio. All a ratio is basically, it's a ratio. It's got something in the numerator, something in the denominator. We've been using those a lot to our benefit to make units cancel and get down the road, okay? So the textbook doesn't use the term stoichiometric ratio, they use the term stoichiometric factor. But we're gonna pick up those stoichiometric coefficients to make stoichiometric ratios. So here's what that looks like. We're picking on the magnesium reacting with oxygen to form magnesium oxide. We could come up with actually 6 different things to say, 6 different ratios. And depending upon what we knew and what we were trying to get to, we would use one of these 6. So for instance, we could say, relatively speaking, we have 2 moles of magnesium will react with 1 mole of oxygen molecules. We could say that 1 mole of oxygen molecules react with 2 moles of magnesium atoms. What, those are the inverse of each other? We could pick on the magnesium and the magnesium oxide. And this is where sometimes students say, well, Mrs. Snipes, why don't you just reduce those 2's and make them 1's and call it a day? I like these 2's because I can see where they came from the balanced equation. I can pick 2 things to say how they are related stoichiometrically. I could say 2 moles of magnesium will form 2 moles of magnesium oxide. Again, depending upon what problem I'm working, I might need to use that ratio or I might need to use the inverse. One last thing is we could pick on the other reactant, O2, and how it relates to magnesium oxide. From the balanced equation, we know that 1 mole of O2 molecules will form 2 moles of magnesium oxide formula units. Again, these are the stoichiometric coefficients that come from the balanced equation. And then these are ratios that we can use to work stoichiometric calculations. So let's see what this looks like. And I don't have whiteboards, but I am going to do dramatic pauses and watch you guys write these in your notebooks. So this is our first stoichiometric calculation. Now I'm going to start out with, and I don't mean to insult our intelligence, but this is actually a baby problem. We're going to see that, you'll see what I mean when I kind of take it up a notch. But let's just focus on the 2 things we're focusing on. I like to write underneath the equation from the problem. So how many moles of oxygen molecules? So I'm going to find my O2 and I'm going to put question mark moles. So I just kind of put it underneath the species. How many moles of oxygen molecules is needed to react with 0.245 moles of magnesium? So I'll find my magnesium and I'll put 0.245 moles. Okay, so that's my question 1. I have a follow-up question. My question 2, it says how many moles of how many moles of MgO can be produced? So I'll find my MgO. All right, question mark, moles of MgO. By the way, this is again starting with 0.245 moles of magnesium. So you catch what I'm doing here. I do this with some other types of problems. I just kind of pull from the problem and put it under the balanced equation. All right. So to work the first problem, to work both of these problems, we can go from moles of, in the first one, magnesium, to moles of O2 using this ratio, and you're going to do this on the next slide. Notice that if my first term is moles of magnesium and I use this ratio, then moles of magnesium will cancel. I'll be left with moles of O2. For the second, So for the second problem, I'm going to use a different ratio because I'm starting with moles of magnesium and I'm going to moles of magnesium oxide. Again, from the balanced equation, this 2 and this 2, these show up right here. And the reason I put 2 moles of magnesium in the bottom is because I'm starting with moles of magnesium. The reason I put 2 moles of magnesium oxide in the top is because that's what I want to go to. All right, so work that problem. And again, we're gonna use the same one and take it up a notch momentarily. No whiteboard, just throw it in your notebook. That is fun, but I know I should. Right. The first term is moles by instance, you can't just put moles, it has to be moles and G. This is one of those where you have to be explicit or it's not going to work. When you start guiding point 2.1, it's 4.1. Most of it is closed. And once you're going to do it after that term, it's big. You want those names and also I was cooking myself some breakfast at 1 o'clock this morning. What do you think?
No, I'm doing some irrelevant calculations.
Okay. Yeah, so. So that was one of the 6.
So we obviously have one more, oh yeah, one more of oxygen.
Okay, if you've done that one, take a stab at the next one.
This is a very redundant formula. That's a very redundant. You would get.
I guess
You would have a different ratio.
I mean, you do
Okay, never mind. That makes sense.
I feel like this is wrong.
No, sure.
Okay. Sure.
So that's if you over 1. So it's your first trip's going to be 2.5 miles by 2 over 11. And then which one of these would you use to make miles by 2 cancel and the other miles by GR? So which one would you say to and G, right? So put, so the first one's going to be 0.245 miles.
Because 0.2 times 2.
My other option.
Let me pick one of these, or then, but the more energy cancel, and then you have to get the
So it has to get involved in the energy.
Or like a dartboard.
This one.
It's like a balance easier.
Yes, yes. And that's just where I told you a little bit ago when we had the 6 possible ways, little stoichiometric ratios you can get from that reaction. That's where I said some people like saying, well, Mrs. Snipes, I'll just go 1-to-1. Well, you can, but it removes information. Okay, so like Emerald would say, we're gonna take it up a notch, we're gonna spice it up a notch, okay? Because usually, and I don't mean that like it hurt anybody's feelings, but that's kind of a baby stoichiometric calculation. It is though. It is a stoichiometric calculation because all a stoichiometric calculation is you pick one, I'll call it species, you pick one thing that you know, and then you calculate how much of the other thing. That's a stoichiometric calculation. That was a moles to moles. Usually you're going to be faced with this, where this is a grams to grams. Where this is a grams to grams calculation. Okay? So again, and it's not really a trick. What really helps sometimes for if you're dealing with a chemical reaction, this sort of problem, is to pull out the numbers and to superimpose them underneath, I don't know if that's the right word, but you put the numbers underneath the species it's talking about. So what mass of oxygen, so I'll find oxygen, I'll put a question mark grams. What mass of oxygen is needed to react with 0.30 grams of magnesium? So it's a stoichiometric calculation. I know the magnesium, I want to know the oxygen. We also know the deal where what? We have 1 mole of O2 over 2 moles of magnesium. We are going to use that, okay? So in this case, notice that I can go from moles to moles using that ratio, but I can't go from grams to grams using that ratio. But I know how to go from grams to moles. We've done that a lot. We can use the molar mass. So that is exactly what we're going to do. So this actually finally gets to, I put it on the board 5-6 times yesterday, this approach. Now, a lot of times in chemistry, problems aren't straightforward. Well, some are, but this is a relatively straightforward problem, and it takes on this pattern. You start with the mass of the thing you know, mass of the grams of magnesium. You have to go to the moles of that thing, and we've been talking about how you do molar mass. Once you have the moles of the thing you know, then we're back to the problem you guys just did. We can go to the moles of the thing we want to know about, in this case, moles of O2, using that ratio from the balanced equation. But we're not done. Because we don't want the moles of the thing we're trying to get to, we want the grams of the thing we're trying to get to, and we know how to do that too. We can go from moles to grams using the molar mass of that thing. So, yeah, I want to spend a little bit of time, and we're going to do a few, get them under your belt, and let's see how this one goes. So, a lot of times working a problem like this, and you're going to see this on my next slide, is I just knock out the molar mass of everything. Because remember the molar mass, we're going to use the periodic table. On a test, if you have, and you will have a stoichiometric, so you can pull a star into this problem too. You will have one of these on the test. You need to show your molar mass calculations. I know it sounds dumb, but like if you need the molar mass of O2, you have to take 2 times that 16.00 and show me the molar mass of O2. It's a little game we play. Actually, it saves your butt because if you calculated the molar mass wrong, I can go back and see what you did. So let's do this one. So here we go. Oh yeah. So these were screenshots. You can't see them very well, but I pushed these out on Twitter. This is to show you the 5 times that I wrote this pattern. The only thing about these, the things that you're seeing on the board was we were going, it was a different balanced equation. And of course, we knew the mass of something, try to get the mass of something else. In this case, we knew the mass of sodium bicarbonate, try to get the mass of CO2. Mass of sodium bicarbonate, get to mass of HCl. Mass of sodium bicarbonate, all these, try to get the mass of these solids here. So those are all what we're doing now. So I told you, knock out the molar masses using a periodic table. The molar mass of magnesium, I love that phrase, is 24.31 grams per mole. Molar mass of O2 is 2 times 16.00, 32.00 grams per mole. and the molar mass of magnesium oxide, which we're going to use in a follow-up problem coming up. The molar mass of magnesium oxide, maybe it's this one, is 40.31 grams per mole, because we take 1 times 24.31 plus 1 times 16.00. Elements make great passwords. If you're like, I need a password. Well, if you have a periodic table on your phone, which a lot of you do, then you can kind of play around with the symbol, the atomic number, the weight, and all you need to remember is the element. So I like to string these up. So let's do this first one together. What will my first term be? Based on strategy.
Magnesium.
Grams of magnesium, exactly. 0.30 grams of magnesium. So I'm going to now use the molar mass of magnesium you see on the previous slide. How can I use that 24.31 grams per mole to make grams of magnesium? Yep. 1 mole. Now, actually, this is where I'm going to, and I'll call it picky, explicit, I don't know what word you want to use, but you have to include the species. Otherwise, these problems do not work. The reason being because the stoichiometric calculation always involves at least 2 species. Yep, so molar mass of magnesium, 1 mole Mg over 24.31 grams magnesium. So I'm ready for stoichiometric ratio. So if I'm keeping up with things that have canceled, my units of grams of magnesium cancel, I have moles of magnesium. This is the bridge to get to moles of, what am I after, O2?
Yeah.
Okay, good. Moles of O2. So what stoichiometric ratio do I use?
1 mole of O2 over 2 moles of magnesium.
Are we liking that? I'm liking that. He said 1 mole of O2 over 2 moles of magnesium. So do we all see where the 1 came from the balanced equation? This 1 came from this 1, and this 2 came from this 2. Yep, units of moles of magnesium cancel. The previous slide, you had the molar mass of O2, 32.00 grams per mole. So how can I use that now?
So then 1 mole of 2, or flip it, 16 grams.
32.
32
Uh-huh.
grams of O2.
Yep. 32.00 grams of O2 per 1 mole of O2. That's perfect. Yep. String them up, baby. How many significant figures, guys? 2. Tap that into your calculators. See what you get. You want a calculator now?
Okay, I'm prepared.
Prepare calculators, because you'll need them for the next part.
Yeah, that's
Just it bothers me. It bothers me myself because I always get the question wrong. Because it drives me nuts. Because to me that shouldn't matter. Show me what it's supposed to do. Because it'd be more exact than practical. Well, if you're rounding, then you're gonna round it, but this is gonna be this. Why? Because this seems more exact than this. Because that's more of a raw number than the rounded number.
Anybody else want to borrow a calculator?
I don't know why we would be rounding this sometimes.
Okay.
Just because you have yesterday's calculator. It still has.
What are the odds? Okay, so let's do the next one, guys.
Not necessarily.
Dun, 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 dun. Same problem, different stoichiometric calculation. So we can use the molar masses from a few slides ago. So we are given 0.30 grams of magnesium, and we'll talk more about what it means by sufficient amount of oxygen actually on Monday, but I'll put sufficient, so it means at least 0.2 grams, right? And question mark grams of magnesium oxide. So, I'll get you started. See what you guys can do with this. 0.30 grams of magnesium over 1. Molar mass of magnesium. Tons of magnesium.
I'm gonna take the more magnesium.
What's the question again?
You're trying to get to NGO.
Yeah. NGO in moles or NGO in grams? In grams.
Okay. No, we essentially have to do that in order to get.
No, you don't.
So this one, this is small mass. Right. So you see one more volume. Okay.
So, like this is,
I was wondering about that.
right here. So this will be the same, and then be the same, but this will be different, because we're trying to get to NGL instead of TF.
So, yep.
The number around there.
Yeah, the first two terms are the same.
I was wondering.
Yep. I'm digging
See, this is where I'm gonna say.
This is where
No,
we
we
have
have
to
to
figure
do
out
this.
we're trying to get to NGO, not O2. So this is all the information.
Shouldn't the third term be between ocean of energy, because that's what we need in order to have them.
Well, we're trying to get to, our question mark was associated with NGO.
Yeah.
So it's not the O2. So we don't care about the O2. We're focusing on the NG and NGO.
So why do we
Next
put
we're gonna
the two moles of magnesium? Why don't we use 2 moles of energy?
So much.
Since this is what we're searching.
The 2 moles of NGO are on the top, the 2 moles of magnesium are on the bottom, because we're starting with magnesium.
Oh, I see. So then we need
Yeah.
and then we're left with energy.
I guess that's what we have. So you have, go ahead and kind of check your answer with the board now. And go on to the next problem. What, there it is. So, how do we? Yeah, I promise you're gonna be doing some of these. These are very practical. It's like cooking in chemistry, you need to be able to do stoichiometric calculations. So we did, yesterday, we counted on the fact that what we started with, the mass that we started with should be equal to the mass that we end with, except our CO2 left. And so we use that to our benefit. But there's no, well, unlike the CO2, there's no gases in this. So you would expect, well, even if there was a gas, you still could account for it, you know, you couldn't weigh it in the lab. We would expect that the mass that we start with would be equal to the mass that we end with. We had 2 reactants. We said when you have 0.3 grams of magnesium, it's going to consume 0.20 grams of oxygen, and it's all going to form 0.50 grams of magnesium oxide. So it all works. So life is balanced.
Question. Can we end up, if we had a question like that on the exam, can we just find the,
You won't have one like that on the test.
oh, okay.
By difference.
Yes.
Or by, in this case, not by, depending upon what you're after, in this case, by
By the
ending.
sum, yeah.
And then what I usually tell students is, you can, if you have it like on an SAT or something, or GRE or whatever, I wouldn't suggest it, because if you made a mistake, then it's gonna propagate through. So I would suggest going back to the drawing board. So we're gonna mix it up a little bit. Here we go. I have some pictures to show you. I actually looked at those recently, so we're gonna jump right to the question. It says, what mass of P4, so I'm gonna find my P4, I'm gonna question mark grams. That's important, because actually that drives what stoichiometric ratio I'm gonna go with. What mass of P4 is needed to react with 1.25 grams of Cl2? 1.25 grams. That's gonna be my first term, isn't it? 1.25 grams of Cl2. My first term. Okay? So we're going to knock out molar masses on the next slide. Here they are. P4, you take 4 times 1 phosphorus, which is 30.97. Round to 2 decimals, you're looking at 123.88 grams per mole. For the Cl2, we're going to take 2 times 35.45, which gives you 70.90 grams per mole. And we're going to have a follow-up question, so we're going to want to know the molar mass of PCl3. So we're going to take 1 times how much phosphorus weighs, 30.97, plus 3 times how much chlorine weighs, which is 39.45, and get an overall 137.32 grams per mole. So jot those down so you can use them to work the problem. So let's work this first one together. What's going to be my first term, did I say? Yep, 1.25 grams of Cl2 over 1. So I'm going to go for now from grams of Cl2 to moles of Cl2. What does that term look like? I'm going from grams of Cl2 to moles of Cl2. Yep, from the previous slide.
So is it over 35.45 or 70?
It's over the 70.90.
Okay.
Yep. Oh, it's how much the compound weighs. Yep. So 1 mole of Cl2 over 70.90 grams of Cl2. Again, you gotta include the species this time. All right, so my grams of Cl2 have canceled with the first 2 terms. I have moles of Cl2. My question mark was with, bless you. My question mark, was it with the PCl3? I get my problems mixed up. Okay, with the P4. So I'm trying to go to P4. So what does that next ratio look like? Your hint is you're going to use this number, which is 1, and you're going to use this number, which is 6.
1 mole of P4 over 6 moles of CO2.
I'm digging it. That's what I would do. 1 mole of Cl2. Sorry, I'm sorry, my bad. 1 mole, what's up there? 1 mole of P4 over 6 moles of Cl2. Perfect.
That will give us the moles of P6.
That will give us the moles of P4.
We should convert it to grams.
We have one more thing to do. We need to convert it to grams. So what does that term look like? P4 term. P4 for moles, P4 grams.
122.88 over 1 mole.
Yep, 123.88 grams P4 over 1 mole of P4. Now moles of P4 cancel, we're left with units of grams of P4, and it's a wonderful thing. So tap it in and see what y'all get. Yep, I heard someone say 3 sig figs. That is correct.
I see page one, maybe the blue one. Everything was out.
So, did I say that we wanted his own test? I did say that we wanted his own test.
Well, Addison's not gonna do it. I hate stoichiometry. Hated it in high school. Hate it.
It's okay, maybe.
I can do everything after it.
Well, the other thing about stoichiometry, and I'm not trying to give anybody pause, but it's kind of a foundation for other things we do in chemistry. So it's here to stay. Okay. So what I want to do is we're going to take a look at that last problem. Here's that last problem, and I said that we'd be short today, but we don't. We only have like 5 minutes of class time. I want you guys to, on your own, see what you can do with this. Okay? That looks busy. It looks busy. Welcome to chemistry, right? But let's take a look at the questions. And I'm a stickler in what I've been telling you. I mean, why have a bunch of numbers and letters and have it just look like mishmash to you? Why not take it and dissect it a little bit? You do that in anatomy. So here we go. I see a number, grams with O2. I'm going to put that under my O2. 0.143 grams of O2. I see a question here. What mass of each reactant? What are my reactants there? Yep. And actually, I'm going to be more specific. My reactants, to me, don't have anything to do with the 3 or the 4. The 3 and the 4 are just specific to this particular reaction. So I'm going to say my reactants are TiO2 and BRF3. Okay? So I'm going to call this 1A, question mark grams 1A, question mark grams 1B. Yep. So the other one is the products. So for number 2, basically, again, I'm starting with that 0.143 grams of O2. And I have a question mark grams of the TiF4. I'll call that 2A. And a question mark grams of the BR2. And I'll call that 2B. You guys already have these, right? Okay. Work those problems.
Can you not? Thank you.
So you're gonna start with the mass, the O2, O1. Source, support, hold, if you're going to 281. Then you move the next one, so your 10 minutes, the 2 moles or 2 using its long mass. Let's go to the ball of the top. 2. Then we can go from moles 1, 2 to, let's go from moles 1, 2 to moles TI. So do the ratio 7. So you can actually use that.
Right, so TO2, just put it,
No, so for this one, this is the surface ratio, you're gonna pick, it's gonna be 3 moles from O2, 3 moles of TiH.
So then this one's 3 moles of O2.
So you're gonna put 1.3 grams of O2 in. And then you're gonna use the mole mass to get moles of O2. This one would just be to that one right here. Now this is because well, no, there's 3 and 3.
Oh, okay.
It's inversion.
And even if you don't tap it in your calculator, if you just at least set it up, I'll be coming back in.
Okay, so you still have to go, so you still have to do
This one, no, because actually this one, you use the, moles of O2 in the top, and we just 3 moles of TI, 2. And then you're gonna use the mole mass of TiO2.
So are you not going to add it?
Oh, I see. So you did have a 3 there.
Yeah, that's a three, that's a three.
Oh, okay, yep, I think that's good. Yeah, that was good.
And then, yeah, they.
It's a little.
Yeah, yeah.
Yeah, that one's good, right number.
I can still.
The TI
Use this
The
one.
first 2 terms would be the same. But the third term would be different.
Yeah, so we can put this, and this. Can I still use this as 4?
It would
So it would
be,
be-
so these two terms would be identical, and this would be the
Yes. Okay, so I can still use this, so I wouldn't have to find this first.
Right.
This.
Right.
Okay.
Yep.
Because you have this mixed up with one whole, because it has to cross over, you have to be able to.
Yeah, that looks right.
It should be one whole.
It's a scratch surface,
Yeah.
That doesn't look right.
So now we're trying to find the merits of the DR3.
So I know that some of you guys are bumping up against time. I'm fine with what you, go ahead and show you the things in the next slide. So,
Yeah.
here are the answers for the first one. If you want to jot these down and work them at home. And then, actually, I think my PowerPoint slides are up in Canvas too. And I'm also recording it, so. Ready? And here are the answers for the second one. I can go back, some of you have to get going, so there's the answers for the second one. Like I said, I'm recording it and posted it in Canvas. Does that make sense? Does it make sense?
Did you still there?
So much more below.
Okay, so then you want to go. So now we want to go.
My old friend.
I didn't get it in high school, I don't get it now, it doesn't make sense.
Well, if you say you can or if you say you can't, you're right.
Okay, so
So-
then we
I truly believe you can't do it. Yeah, that's for sure. I've been there, done that.
is the 4.
Nice shirt. I didn't get one this year. Was that it this year, sir?
So I've been working on irritating time,
Okay.
getting it finished, because like I'll be doing problems, and I literally, I know how to like, set them up and I know what I need to, but I have issues with like the half ones I have issues with.
Okay.
You know, you do one over and you have to multiply it to, and then I'm always like off by like 2 rounding.
Okay.
So I am behind in it, I just want to let you know. I'm
Okay.
trying to get it finished.
Well,
So
remember
quickly.
and I need to tell this to everybody, so like,
I've been even writing it down, like it's
see if you're writing it down, start hanging it. So if you've been writing it down, actually Monday I'll try to take it on Fridays, but if you've been writing it down, you get 50 points. So if you get half of the alpha problem, that's 50 points, you know what I'm saying? And that's like 100.
You want to look at mine and see if I'm like writing it down.
Because it's slowly
I bet
getting.
you
It's like.
Because like, I have multiple papers of it, so I know I'm ready.
Yeah, I do too. I have mine.
Okay, good. Yeah, I'm just gonna,
So later we'll.
yeah, that was good.
Cause like this
Very
is
good.
all my altar, I'm working, going through, but I can set it up right, I'm just having issues, I just wanted to know that I'm slightly behind.
Well, that's, you know, like I said, I really think by the time I add those points in, I think you're gonna be fine.
Okay.
So it could be, you just wanna take a deep breath and then go on to the next part,
Okay.
okay?
But
Yeah.
I came back to the first one like 10 times.
Because this one I say wrong. When I'm having issues with it, I just moved on to other ones. I got one completely finished. And I have one partly finished. And I have another one partly finished. Just have another.
And I gotta order her shit. She wants two silver rings.
She hates the round.
And then
I just want the best for everybody.
hair like
I wonder if she does maybe, because she,
or
you know,
like
sad and having that problem up there. I
if I
get
can
it.
get five.
I did it in high school. I'm sure.
I know. I was like, oh, that was.
So, yeah, maybe just kind of, and cause I got you, I don't know, you did, I'll give you the 50 points, and did you guys write stuff down for Alta this time? I was gonna do that Friday, so I'll probably ask him Monday too.
My
Okay.
I have one. It's in here somewhere. Oh. I got it. Yeah, and then
Aw.
from Keyword. I honestly think I hate Florida. I really don't like Florida at all. I went last September. Oh, really? I think I might go. My sister lives there.
But if you did it, I'll let you get on the field.
Okay, because I did. Do you remember me
You were
writing
scribbling all over the place.
Yes.
Because it's in my backpack.
You definitely have to have like something.
Yeah, very good.
Just do it.
I don't think so.
Because I'll even give it to you Monday. Yeah. 'Cause
So
I-
each Friday, Fridays, I'll take a look and then dump those points in.
Because I wrote them down for not yesterday's, but the last ones. But I'm doing yesterday's today. Because I didn't have
Yeah, I've been working at 12 nights. That's fun.
Where do you work?
we both work at Big Boys.
It's so fun. Some days.
Some days it's
Yesterday was rough.
yeah, yesterday.
I can see it take a lot out of you, physically and emotionally and mentally.
Oh yes, definitely. But I will give those to you Monday.
Olivia's
Sounds
had many mental breakdowns.
Yes, many.
good.
Thank you.
Yes.
But I mean, so have I, and this is better.
I don't blame them. I can have mental breakdowns. In different ways.
You're so with it. Is this for your
It's for my project in
on people and things like that?
anatomy. And it's my cell. I'm just finished. Like I didn't have my book was in my car, so I couldn't. And I just have to print out paper.
That looks like should be Instagram quality and something to post. That's on Instagram.
And then last night at work, I was doing homework. I was like, I do homework. We got slammed at 7 o'clock till like 10